Have you ever wondered why the fruits become lighter after drying? Have the fruit disappeared? Of course not.
The answer lies in water content. Water is a major component in fruits and vegetables, making up a large percentage of their total mass.
Scientists can determine the amount of water present in a food sample before and after drying.
This process is widely used in food science, agriculture, and quality control.
Today we will investigate about the mystery of missing water using apple slices as our example.
This is a serious case. We need to find the missing matter.
Could someone have stolen it?
We will investigate. Sugar, you steal the bake?
No, I've been inside the apple the whole time.
What about you?
I'm still here too.
Why are you looking at me?
Suspicious. We need evidence for making any accusations.
Detective, the weight dropped by 40 grams.
Interesting. I have solved the case. It was you, right?
Okay, fine, I confess.
The missing weight wasn't stolen. It wasn't like the
Hello, I'm going to be talking about the importance of weighing. Weighing doesn't only determine the weight or the mass of certain products, but in chemistry, weighing has a lot more than that. There are specific reasons why weighing is really important, especially in the chemical industries. Weighing in chemistry is the foundation of accurate experimentation and safe production. It allows chemists to calculate the exact stoichiometric ratios, determine yields, formulate stable pharmaceutical dosages, and maintain strict quality control. By using weighing systems that offer precision and accuracy, manufacturers can ensure that every batch meets the required chemical specifications, leading to better product quality and consistency. In manufacturing, from pharmaceuticals to food and beverages, batch consistency is heavily regulated. Accurate weighing prevents contamination, ensures the right percentages of ingredients, and verifies that every product performs identically. Automatic weighing systems ensure that hazardous chemicals are measured correctly. This reduces human error and the risk of accidents in the workplace.
Before we start, we should know the terms of sampling. Sampling is a process of getting a representative and homogeneous sample. To be more understanding, it's like we take a certain part from the main part to measure the quantity or quality of the sample we take. For sampling method, it's divided into three parts, which is solid, liquid, and gaseous. As for sampling solid method, the sample is randomly selected and assumed to be representative. The larger particle size, the larger the gross sample, which is reduced to obtain a laboratory sample. And one of the example is cone and quarter method for material analysis. As for sampling liquid method, it's homogeneous and easy to sample. The gross sample also can be obtained small. And lastly, sampling gaseous method. This method requires large volume due to low density. It also requires liquid displacement method for minimal solubility. Other than that, microwave and oven also used for sample dissolution. We've used this method, it provides rapid and efficient drying and acid decomposition. It also reduces times from hours to minutes and low blank levels due to reduced reagent amounts. Like in this video, we use the apple as the sample to determine the water inside of it evaporates or not. To sum up, sampling is important to identify the specific sample and get the exact amount of the analyte.
Let's moving on to drying sample. The primary purpose of this step is to ensure that an exact weight is obtained during quantitative chemical analysis. Please note that this specific step applies to solid samples. For the standard method, solid samples are dried in an oven at a temperature range at 105 degrees Celsius to 110 degrees Celsius for 1 to 2 hours. However, there are a few problems associated with the drying of samples that we must watch out for. First, samples might decompose at high temperatures. For samples that are sensitive to heat, the drying process can be carried out in a desiccator instead. Second, we risk the loss of samples. And third, we must prevent contamination. Now, once our sample is properly dry, how do we weigh it? We determine our weight by making a very careful measurements using an analytical balance, but in quantitative analysis, weighing a sample just once is not enough. To ensure our data is highly accurate, we prepare and weigh replicate samples. This simply means we divide our material into multiple portions of roughly the same size and we run them through the exact same laboratory procedure at the same time and in the exact same way. Doing this is crucial because it improves the quality of our results and gives us a reliable measure of how trustworthy our data actually is.
Hi everyone, today I'm going to share with you a quick breakdown of dry etching, which is widely used thermal decomposition method in analytical chemistry. Let's look at its pros and cons so you can decide what is the best tool for your analysis. First, let's talk about why do scientists love dry etching. The first advantage is simplicity. It is incredibly straightforward to set up because few or no chemical reagents are added. Your samples remains completely free from chemical contamination. Second, it gives you the unique ability to decompose large sample size effortless. On top of that, it's a relatively safe technique to run in the lab, and it is easily lends itself to mass production, which means you can process multiple samples at the exact same time. However, dry etching isn't perfect. There are a few critical disadvantages to keep in mind. The first disadvantage is sample loss. You can experience retention losses where elements stick to etching container or volatilization vaporize away. Also, it is a slow process. You typically need 2 until 4 hours just for the dry etching to complete. Furthermore, there is a risk of physical contamination coming from both the muffle furnace walls and the containers themselves. Lastly, you have to be very careful when opening the furnace door. Air currents can cause a physical loss of low-density ashes. In conclusion, while dry etching is safe, simple, and perfect for large-scale baths, you must carefully monitor your temperature and handling to prevent element loss.
Now, I would like to explain some precautionary steps that should be followed during this experiment. First, all samples should be prepared with the same size and amount. This is important because different sample sizes may dry at different rates, which can affect the accuracy of the result. Next, the weighing balance should be checked before use, and the same balance should be used throughout the experiment. This helps to reduce measurement errors and makes the result more reliable. During the drying process, the sample should be dried until it reaches a constant weight. This means the weight does not change anymore after repeated weighing. If the sample is not completely dry, some water may still remain and the water content will not be measured accurately. After drying, the sample should be allowed to cool before it is weighed. A hot sample can affect the balance reading and give an inaccurate measurement. Finally, the equipment should be clean and the sample should be handled carefully to avoid contamination or losing part of the sample. By following all these precautionary steps, we can reduce errors and obtain accurate and reliable results.
In conclusion, this investigation demonstrates how water content in foods can be determined through drying and weighing.
The difference in mass after drying represents the amount of water that evaporated from the sample. This method is commonly used in food analysis to assess food quality, storage conditions, and nutritional properties.
The mystery of missing water has been solved. The missing mass was water that evaporated during drying process.
From the dusty mesa, her looming shadow